So we're going to look at simultaneous equations today. This talk is based off an OCR module on simultaneous equations that I found on the internet, and it just shows you all the different examples that we can use to solve simultaneous equations using algebra. So what are they? They're basically two equations in x and y that are the two unknowns. And when we solve these equations, what we're trying to find is values of x and y that both work in the equations and both satisfy or solve the equations at the same time. The method we're going to look at here is called the elimination method. So here are our two equations, 2x minus y equals 1, 3x plus y equals 9, and what we're going to do is try and solve this by eliminating either the x or the y and then solving for what's left and substituting back in. That's the whole plan. The first thing we're going to do is label our equations, and then we're going to look at the coefficients in front of the numbers. Here there's a 2 in front of the x, and here there's a 3 in front of the x. But here, if you look, we don't usually write it, but there's a 1 in front of this y and there's a 1 in front of that y. So basically we have the same number of y's. I know we usually take account of the sign, but at the moment we're just looking at the numbers. Because we've got a minus y and a plus y, we can eliminate these by adding these equations together, because minus y plus y will leave us with 0y. So what we're going to do is we're going to add the equations together and make the y's disappear. And if we do that, we get 2x plus 3x is 5x, the y's are going to disappear, and 1 plus 9 is 10. Now we just need to work out what x is, so if we divide both sides by 5, we get x equals 2. That's the first part of our equation solved. We now need to find out what y is. If we substitute x equals 2 into either of these equations, we can find out what the y is. Here we're going to substitute it into this first equation, and if we do that, we get 2 times 2 minus y equals 1, from which you can see 4 minus y equals 1, therefore y equals 3. And we found our answer. X is 2 and y is 3. We can just double check that. 2 times 2 is 4, minus 3 is 1. And in B, 3 times 2 is 6, plus 3 is 9. So it looks like it's all worked nicely. Now let's look at another example. Similar to the last one, 5x plus y is 17 and 3x plus y is 11. Here, the numbers in front of the y's are again the same. We've both got 1 here, but this time both the signs are positive, plussing, adding. So if we want to try and get rid of the y, we could take this equation and subtract this equation from it. Then we've got y, take away y, which would get rid of our y's. So let's do that. We're going to subtract the y's, and 5x minus 3x is 2x, y minus y is 0, and 17 minus 11 is 6. Then we can work on our x, divide both sides by 2 to give us x equals 3. Again, we can substitute x equals 3. We're going to do that into this equation A. That gives us 5 times 3 plus y is 17. 15 plus y is 17, so y has to be 2. Again, our answer is x equals 3, y equals 2. We can check that. 3 times 3 is 9, plus 2 is 11. And 5 times 3 is 15, plus 2 is 17. Let's look at another example. We seem to have concentrated on the y's, so let's look at the x's. Here we've got a 3 in front of this y and a 1 in front of this y, but we've got 2's in front of both these x's. They're both positive, so to eliminate them, what we have to do is subtract again. If we subtract these two equations from each other, the x's will go, and we'll have 3y minus y, which will give us 2y, and 9 minus 7 equals 2, from which we get y equals 1. We can then put that back into the first equation. 2x plus 3 times 1, which is 3, equals 9. And rearranging that gives us 2x equals 6, and therefore x equals 3. So our answer is x equals 3, y equals 1. Check. 2 3s are 6, plus 1 is 7, and 2 3s are 6, plus 3 times 1, which is 3, 6 plus 3 is 9. So everything looks good. Here's another example. This time, instead of them being equal to 1, we've got the y's, and the number in front of the y is 3. This is a minus 3, and this is a plus 3. So this time, what do you think we're going to do? To get rid of these, if we combine these by adding the equations together, the y's will disappear. If we do that, we get 6x, the y's disappear, and 14 plus 16 equals 30. Divide both sides by 6, gives us x equals 5. We can put that back into equation A. 4 times 5 is 20, minus 3y equals 14. A little bit of rearranging gives 3y equals 6, therefore y equals 2. Now our answer is x equals 5, y equals 2. Let's double check. 2 5s are 10, 2 3s are 6s, 10 plus 6 is 16, and 4 5s are 20, 2 3s are 6, 20 minus 6 is 14, so everything's working out fine there. So let's now recap. How do we do this? We look at the equations, we check to see if it's got the same number of x's or y's. If the sign is different, we add the equations. If the signs are the same, we subtract them. We have one equation in either x or y, we solve this, and we substitute that answer back into the other equation and check that we've got the answer correct. Okay, so far we've looked where the coefficients in front of the x's or the y's are the same, but what if not the same? Here the coefficients in front of the x's are 3 here and 5 here, 1 here and 2 here. So what can we do? We need to try and get rid of an x or a y, and no easy way to do it. Let's see what we can do there. Let's first label the equations. Now if we look at this equation A, if we multiply this by 2, we'd have 2y here. But we have to remember that if we do this, we've got to multiply the 3x by 2 and the 10 by 2. So our equations will become 6x plus 2y equals 20 and 5x plus 2y equals 17. Now we're back to our old story. We've got the number in front of the y's is the same. They're the same sign, so we subtract them, which will give us 6x minus 5x equals x, and 20 minus 17 equals 3. Therefore, we've got x equals 3. We're going to substitute into b. So 5 times 3 is 15, plus 2y equals 17. 2y equals 2, and y equals 1. So our answer is x equals 3, y equals 1. Let's just double check that. 3 times 3 is 9, plus 1 is 10. 5 times 3 is 15, plus 2 times 1 is 2, and we seem to have shot on again. Okay, let's try this one. We've got 4x and 3x, which is not good, and 2y and 6y, which is again not good. If we multiply the first one by 3, we're going to get a 6y here, so let's do that. Now we've got 12x minus 6y equals 24, and 3x plus 6y is 21. The signs are different, so we add them together. That will give us 15x, the y's cancel, and 24 plus 21 is 45. If we divide through by 15, we get x equals 3. We substitute that back in B. 3 times 3 plus 6y equals 21. Therefore 6y equals 12, y equals 2. And our answer is x equals 3, y equals 2. Let's double check. 3 3s are 9, 2 6s are 12, 9 plus 12 is 21, 4 3s are 12, 2 2s are 4, 12 minus 4 is 8, and everything's happy. Now for the final example. Here we've got 3x and 5x, 7y and 2y. Let's label those, A and B. Now, there's nothing simple where we can just multiply to get the x the same or the y the same. We have to multiply both equations this time. If we multiply A by 5, we're going to get 15x here. And if we multiply B by 3, we're going to get 15x here. So if we do that, multiply A by 5 and B by 3 to get 15x, then the equations become 15x plus 35y equals 130 and 15x plus 6y equals 72. Numbers are the same at the front, signs are positive, so we subtract. And if we subtract, the x's will go, we're left with 29y equals 58. If you do a little bit of division, y equals 2. We can substitute that back into here, which gives us 5x plus 2 times 2, which is 4, equals 24. So taking the 4 over, 5x equals 20, and x equals 4. So our answer is x equals 4, y equals 2. Let's double check. 3 4s are 12, 2 7s are 14, 12 plus 14 is 26, 5 4s are 20, 2 2s are 4, 20 plus 4 is 24, so everything looks good. So let's look at one final example. 3x minus 2y equals 7, 5x plus 3y equals 37. Let's label our equations, A and B. Looks like here, if we multiply the first one by 3, we get 6y, and if we multiply the second one by 2, we're going to get 6y. So, if we do that, we get 9x minus 6y equals 21, and 10x plus 6y is 74. The signs are different, so we've got to add them. And if we do that, we get 9x plus 10x is 19x. And 21 plus 74 is 95. A little bit of rearranging, dividing by 19 gives x equals 5. If we then substitute that back into equation B, we'll have 5 times 5 plus 3y equals 37. 25 plus 3y equals 37. Take the 25 over, 3y equals 12, therefore y equals 4, and we get our answer. We could have also multiplied A by 5 and B by 3, again to get 15x, and done it that way. It will give you exactly the same answer.